Welcome to our video on fundamental theorem of calculus, part 2. So it's just these problems is all we're doing today. It's a little bit of a mixture of everything with a little bit of FTC, a little bit of just properties as well with integrals. So let's go ahead and tackle this. So for the first problem, we're given f of 3 is equal to 5. F prime is continuous, and integral from 3 to 8 f prime dx is 20. Let's go ahead and find the value of 8. All right. So all we're going to do here is just rewrite this and pretty much just set it up. Okay. So I know that 3 to 8 of f prime of x dx using the fundamental theorem of calculus is f of 8 minus f of 3. So all I'm going to do once I have this set up is just substitute everything in, and then it becomes a fairly simple problem. So this part right here, since it's equal to 20, I can just replace this entire thing with 20. So 20 equals, I do not know f of 8, but I do know f of 3 is 5. And then pretty much I'm ready to go. So f of 8, if I add that 5 over, it's going to equal 25. So a fairly straight version of the fundamental theorem of calculus. This one was not a calculator problem. This one does not have a table, but it just gives us everything we need right in there. Okay. All right, let's go below that. I think that's actually the only FTC problem here. Other ones are just using properties. So if we have that the integral from -1 to 3, sorry, -1 to 4 of 3f of x plus 2 is 28, we need to find the integral from -1 to 4. So what I'm going to do is use some of my properties here. So it's not really distribution, but it's an addition property of integrals, is that I'm going to do the integral from -1 to 4 of this 3f of x dx, add that to the integral from -1 to 4 of 2 dx. Okay, and again, that's going to be equal to 28. So it's almost like I'm just solving for a variable. Oh, let's get that better picture there. Nice. So I'm trying to solve for the variable of this integral from -1 to 4 of f of x dx. So let's do a couple of things. First off, let's pull that 3 out. So there, I'm ready to solve for this. From -1 to 4, you do need to know what this value is. Okay, so this is a rectangle of height of 2 and a base of 5 because I'm going from -1 to 4. So if it's a rectangle of height 2, base 5, this is going to give me an answer of 10. All right, and if you did not know that and you want to do a little bit of side work and actually figure this one out, not using geometry, well, you could just integrate from -1 to 4 to dx is the same thing as 2x from 4 to -1, and then this would end up giving you a 10. So you can do that using some calculus as well. So once we're here, we know that 3 integral from -1 to 4 fx dx is equal to, subtract that 10 over, and we're going to get 18. And this is almost by itself. I said to divide that 3 over. So when I divide that 3 over, I'm going to get 6. So my final answer here is just going to be 6. So this one wasn't FTC. It was just using my properties of integrals. Okay. And that's the problem. So today's note's not very long, which is totally awesome. So we have a piecewise function here. So when it's less than 2, we have this 3x plus 1, and when it's greater than 2, we have this x squared plus 1. Okay. So we're going to evaluate from -1 to 4. So what we're going to do is we can actually break this up from -1 to 2. So this is the left side, so we're going to integrate 3x minus 1 dx. And then add that to, what do I have left to integrate? Well, from 2 to 4. And that's going to be right here at this x squared plus 1. And I can do this, by the way, because this is a continuous function. How could you test if it's continuous? Just plug in a 2. All right, if it's not continuous, then there's actually a little bit slightly different technique we have to use. but we're not talking about that right now. So it's safe to assume that it is continuous. And yeah, you plug in a 2, it is continuous. You are good to go here. If it wasn't continuous, then we'd have an extra step of stuff to do. But I digress. So here we go. So I have 2 problems here. So I'm going to get 3 over 2x squared minus x. I'm going to evaluate that from -1 to 2. Plus, when I find the antiderivative of x squared plus 1, I'm going to get 1/3 x cubed plus x, 2 to 4. So this is going to give me a 3/2 times 2 squared minus 2, all supposed to be in parentheses, minus 3/2 times -1 squared minus -1. Find that answer out, and then add that to this 1/3 times 4 cubed plus 4, and that's all in parentheses, minus 1/3 times 2 cubed plus 2. So you can go ahead and do all that arithmetic if you want to. You can hit pause. Go ahead and go through with that. I have my little cheat sheet. I have my answer already. And I'm going to get an answer of, and you add this all up, because again, I don't want the notes to be so long. You get 133 over 6, and you can always check that on your own. Okay, so that's it for FTC day 2. Just really had one problem of it, and then we're just using properties down here in these other ones. So, that's all.